I'm getting used to having Melissa take care of everything for me, and she's so good, but she said she's going to be a little bit late today. Okay. So I just want to look at this last question. Um, Let me just give, does anybody still need time to copy this? Anybody need more time? Okay. So then I'm going to go on and I'm going to erase that first one so I can put this one just running out of space. So we have this question, 3y over 2 minus y over 6. And this is what we were talking about the other day. Okay, just be on Tuesday, where we started talking about how do we combine fractions? How do we combine rational expressions? By the way, this type of question would not be on the midterm because this is really from chapter 5. When we're adding and subtracting fractions, you have to remember that what you need is a common denominator. You need both fractions to have the same denominator. Now, in this case, it's sort of easy to pick out the common denominator because the denominators are just plain numbers. I'm going to do the next one. I'm going to do one that has variables in it, and that's really going to take us to where we have to be. So if my denominators are 2 and 6, remember an LCD is a number that both denominators will divide into. It's not a common factor, it's a common denominator. It's the bigger one, not the smaller one. If you notice, 2 divides into 6, and certainly 6 divides into 6. 6 divided by 2 will give you 3. 6 divided by 6 will give you 1. Since both numbers will divide by 6, we can say that 6 is our LCD, our least common denominator. If you had done something like doing 2 times 6 and pick 12, that would have been a common denominator. It wouldn't have been the least common denominator, and it would have worked, but you would have had more work at the end because you'd have to simplify more. So we try to find the smallest denominator that both of the denominators will divide evenly in. Now, I think it's easiest to do one directly under the other. In other words, so you can compare the original denominator with the new denominator. What we're going to have to do is rename the numerator as well. We can't just put 3y over here because then we would have changed the value of the fraction. So we have to see, what did we multiply the 2 by? Well, if I do 2 divided into 6, I divide the denominator, the original denominator, into the new denominator. And I 2 divided into 3. I'm going to just put it on the side so I keep it in mind. You don't have to write it there, but it's good to keep it track. I have to multiply the numerator by this 3 as well. 3y times 3 will give me 9y. Again, let's go through the steps. Take your original denominator, divide it into your new denominator. Whatever you're left with, that's what you're going to multiply the numerator by. Do the same thing with your second fraction. In this case, really, you don't have to do anything because you didn't change the denominator. You don't have to change the numerator. But if you think about it, 6 divided into 6 would give you 1, and 1 times y will give you y. Once you have a common denominator, once both fractions have the same denominator, then you only work with the numerators. Your answer is going to be, I'm going to erase this now so I can get more space. The 9y minus the y all over the 6. In other words, now you're going to put everything over the 6. And 9y minus y just gives you 8y. Now you don't have to, you could have just right away done 9y minus y and gotten 8y. And you put it over 6. And the last step you want to do is see if you can simplify your fraction. Can you reduce the fraction? And since these are just monomials, all you have to do is look for something that divides into both the numerator and the denominator. Remember, with binomials, you have to have a whole, it has to be exact. But with the monomials, you just have to be able to divide them by the same thing. And 2 divides into 8y and gives you 4y. And 2 divides into 6 and it gives you 3. I can divide numerator and denominator by 2 so that my final answer in the simplest form is 4y over 3. Any questions about this? All right, I'm going to give you one to try. Okay, I'm going to do another one or 2, and then I'm going to give you some to try. Okay, can I erase this? Okay.
Yeah.
Okay. By the way, don't forget tomorrow is the midterm. You do not sign into Zoom. You sign into Blackboard. I think I have it opening up as early as 9 o'clock, but it's officially between 10 and 11:30. And you have approximately an hour and 20 minutes to complete it once you start. Okay, I see Melissa's here, so I'm going to take advantage of having Melissa here and make her the host. Good morning, Melissa.
Good morning.
Okay. You're the host now, so you're going to,
Okay.
oh, I'm sorry, I made Ashley the host. Press the wrong thing. Let's do this again. Da, 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 da. Oh. I can't do anything now. Ashley? Oh, I can, oh, sorry. Okay, I'm the host again. Okay. I by mistake made you the host. I meant to make Melissa the host. Okay. Okay. Yes, okay. Melissa, you're the host now.
Okay, I see it.
Okay, great, thank you. Okay, so we're going to do another type of example. Where we're going to combine we're going to combine our fractions. Okay, so let's say I had this. 5 over 8x minus 10 over 2x squared. Okay, again, we are, you know what, let's make it a plus instead of a minus. We don't only subtract, we very often add. But again, the rules for adding and subtraction of fractions always means you need a common denominator. Okay, now what's different about this one is because we have x's as well in the denominator. But again, our denominators are all single terms, they're monomials. So when they're monomials, we look first for the common denominator between the numbers. What number will go into both 8 and 2? And I guess everybody will realize that that number is 8. And when it comes to the letters, when it comes to the variables, there's an x and an x squared. What you take is the one with the larger exponent. See, it's just the opposite of what we do when we're finding a common factor. When we're finding a common factor, we go to the lower one and we pick the smaller exponent. When we're looking for a common denominator, when we want to add, we need both denominators to turn out to be the same, we pick the larger one. And between x and x squared, my common denominator then would have to be the 8x squared. Once we've picked out the common denominator, we're going to change each fraction to, we're going to rename the numerators so that we're not changing the value of the fraction, that we're not doing anything to, we're just changing the way the fraction's being written, just like we can write 4 over 8 instead of 1 over 2, but it's still going to have the same value. Again, what do? We divide the denominator, the old denominator, into the new denominator, the top one into the bottom one. Well, when I divide 8 into 8, that just cancels out. And when I divide x into x squared, it leaves me x. In other words, dividing 8x into 8x squared gives me x. I have to take this x and multiply it by the 5. So x times 5 will give me 5x. I then go to my second fraction. And I see that the 2 divides into the 8 and gives me 4. The x squared into the x squared, it cancels out. So all I'm left with is 4. Take this 4 and multiply by this numerator, and I get 4 times 10, which is 40. So now both fractions have the same denominator. All I have to do is add the numerators. Once they have a common denominator, I only work with the numerators. If it's plus, I'm adding. If it's minus, I'm subtracting. So I'm getting 5x plus 40 in the numerator. Notice that I couldn't add them any further because they're not like terms. And I put it over the common denominator, which is 8x squared. And then I try to simplify if I can. Now I notice in my numerator that I can factor out a 5. The numerator could also be written as 5 on the outside, x plus 8 on the inside. And that's still over 8x squared. But it doesn't allow me to cancel anything out because this is an 8 and this is a 5. I can't cancel out this 8, which is inside the parentheses, so that's a unit. With this 8 that's not inside of parentheses, I can only cancel out an x plus 8 with another whole x plus 8. I don't have that. I can write my answer either in the first format or in the second format. They're both acceptable answers. Is there any question about this?
Yeah, good morning, this is Jonathan. My question is, for example, you said 2x squared and 8x, and then you turn it to 8x squared. So you always make it the common denominator one with the highest exponent?
Right. The common, I'll say it again, I did say that, but I don't know if it came across. The common denominator, notice of the two numbers, it was the larger number. It's always larger. It can't be smaller. And the exponent is always the larger. It's just the opposite of finding a common factor. Now you're going to the larger thing, not to the smaller. Is that clear?
Yeah, it is. Thank you.
Thank you for asking that question, because it reiterated something that's very important to repeat. Okay. I want to do one more example before I give you one to try on your own. So let's say I had something like this. Is it okay if I erase?
Yes.
No, okay. When I don't hear a response, I assume it's okay. I'm sorry. I know it's hard because you have to turn on your mics. So it takes a little bit of time. Okay, let's say I had something like this. I'm taking this off the sheet that I had given you for the review sheet for after the first chapter after the midterm. Okay, this is different. Before we were dealing with monomials. Now we happen to have polynomials in our denominator. We still have to find a common denominator. We still have to find get the same denominator for both fractions. Now here's the thing. When it comes to polynomials, what we have to do is first factor the polynomials completely. So I look at the x plus 3, and there's nothing, I can't simplify it any further. I can't factor it. But the x squared minus 9 can be factored. That's what we call the difference of squares. It can be factored into x plus 3 and x minus 3. Now I'm going to just put a line through this to say this is my new denominator. So step 1 is factor your denominator. Okay, step 2. Put a circle around, and it doesn't have to be a real circle. It can be a circle in your mind, but I like to actually circle it. I'm doing it with a green pen, green marker. Every single factor from the first fraction. If there were 2x plus 3s, I'd circle both x plus 3s. As many factors as there are in the first fraction, that has to get circled. Then go on to the second. And see, if something already matches, if you already have an x plus 3 circled, you don't have to circle it again. But anything that's not been circled, which in this case is the x minus 3, that has to be circled as well. So it turns out, in this case, I had two things circled, the x plus 3 and the x minus 3. Those are my two different factors that I found in all the fractions that I'm combining. My common denominator, my LCD, is just all the different factors written down together. So it's the x plus 3 and the x minus 3. So on my next line, I just write down my two fractions. It's a plus in between, so I put the plus with the common denominator. Again, the common denominator are all the, notice I didn't even multiply them out. I just line them up one right next to each other, because I want them in their factored form. I want them to be, I can't use it when it's x squared minus 9. I have to use it as in its factored form. Once we found our common denominator, we have to rename the numerator. How do we do that? Notice I told you to put one right directly above it. And compare the original denominator with the common denominator, the new denominator. And check off what you already had. I started out with an x plus 3. I checked that off. The thing that I didn't check off, the one that wasn't there originally, is my x minus 3. That is what I'm going to have to multiply my numerator by. It actually is easier than the monomials because you really don't have to do any division. Once it's factored, it's easy to see. If I had divided this into this, I'd be left with the x minus 3. It just cancels out. I'm left with x minus 3, which means I have to take the x from the numerator and multiply it by the x minus 3. And even though I want my denominators, my bottoms to be completely in parentheses, in the numerators, I don't want anything in parentheses because I'm going to have to, remember, when I finish rewriting them, I have to combine the like terms. If they're in parentheses, I can't do that. So I'm going to multiply the x minus 3 times the x, which will give me x squared minus 3x. That takes care of my first fraction. I then go to my second fraction, and again, I compare. There's an x plus 3 here. There's an x plus 3 here. There's an x minus 3 here. There's an x minus 3 here. Both of these got checked off. They were already there. So I didn't have to multiply my denominator by anything. I did not change the original denominator by anything. I'm not going to change the numerator by anything. Or think of it, I multiplied both of them by 1. So I had to multiply this one by the x minus 3 because that was a new guy in town. It wasn't here originally. But this I didn't have to multiply anything because both of them had already been there. So it's almost just a question of comparing. Now we work just with the numerators. We take and combine all the like terms, x squared minus 3x and a plus a negative 18, which gives you minus 18, and put it over the common denominator of x plus 3 and x minus 3. And I've done all the addition or subtraction of the fractions, but we always want to try to get our answer in lowest terms. So in order to get it into lowest terms, I have to see, can I factor the numerator? So I'm going to go over here. This goes back to what we learned in the first section. How do we simplify the fractions? Well, I have to factor the x squared. I'm going to do the AC method. My AC is going to be the 1 times the negative 18, which is negative 18. So I'll be looking for numbers that will multiply to 18, but when I subtract them, will give me the 3 that's in the middle. obviously that's 3 and 6. And since that middle term is negative, it's going to have to be a negative 6x and a plus 3x. Here, I'll bring down my x squared and my negative 18. And then this factors to x times x minus 6 plus 3 times x minus 6. I'm just working with that numerator first, which gives me x minus 6 times x plus 3. Now you know why it's so important that you know how to factor. And we put it over the common denominator of x plus 3 and x minus 3. And look, now, is there anything to cancel out? I can't cancel out the x minus 6 because there's no x minus 6 on the bottom. But the x plus 3 and the x plus 3 do cancel. Don't make a mistake. This has a 6, this has a 3. They can't be canceled. So my final answer comes out to be x minus 6 over x minus 3. This is about as hard an example as you can get because it involves so many steps. Are there any questions about this? Okay, so then I'm going to put a problem on the board and I'm going to see if you can work out the problem. See if I can come up with one. Okay. Okay, here's a problem for you to try. Can I erase it? No, nobody seems to. Okay, thanks. Oh, I got it too complicated. Okay. X plus 4 over 2x plus 10 minus 5 over x squared minus 25. Okay, we're going to do this in steps. The first thing I want you to do is figure out what is the LCD. What should be the least common denominator? While you're doing that, I'm going to be taking attendance. Azia? Okay, see Azia is here. Nashia. Nashia here?
Yeah.
Oh, good, thank you. Anna Belkis. Anna Belkis? Emma?
I am present.
Yes, thank you. Messiah?
I'm here.
Good. April? I know you're here. I saw you before. April? I see you. Okay, here, see you here. Kachira?
Good morning.
Good morning. Umar? Umar? I see you're here. Yakima? Yakima Ellison? Cheryl, I know you're here. Okay, Ashley, I see you. So I'll get to you then. Stacy, I see you're here.
Yeah, I'm here.
Stacia.
Yes, morning, Professor.
Who was that? Who just said good morning?
Stacia.
Oh, okay, I saw you came in also.
Okay.
Natalie,
Here.
good. Let's see, Khadija. Khadija, I saw that you were here. Erica? Erica?
Here.
Yeah, I
Good
saw
morning,
you.
Professor.
Good
Thank
morning.
you.
Jonathan, I know you're here. We talked. Luke Minot. Is Luke here? Layla?
Yes, I'm here,
Oh,
Professor.
good, thank you. And Ashley, I know you're here. Kachira, I see, I'm pretty sure I saw you here also. Kachira,
Yeah, I said good morning.
thank you, you did. Jennifer Ramirez, you also I saw before.
I'm here.
Yes, thank you. Rachel Seeley. Rachel?
Good morning, I'm here.
Oh, good. Gloria Villalba. Corey, I'm pretty sure I saw you here also. Corey, you're here, right?
Yes.
Yes, okay. Denisha,
I'm here.
good. Devana.
Present. Good
Yeah.
morning.
I know you're here, okay. And I see Luke, I'm changing you. Luke, you're here. Okay, great.
Professor, you call me?
Who's that? Who just asked me a question?
Umar.
Umar, I did call you and I saw that you were here.
Thank you.
I marked you present. I saw you
Aye.
here. Don't forget, tomorrow is the midterm. You log on to your Blackboard account. Don't forget, everybody, Blackboard tomorrow. Don't Zoom, go to Blackboard and do your test on Blackboard. I will be checking if you have run into any difficulty. I will be checking periodically my emails, so just email me and I will be available to help you out as much as I can. Sometimes the only thing I can do is reset, which means you have to start from the beginning. And if you're at your last question and something happens, you might not want to redo the whole test. Again, each test will be a different test, so it's not as if you're doing the same test all over again. There are many versions of the test, all similar, but they're different versions. The holiday of Passover actually starts Friday night, which means that I will not be available from about Friday afternoon until Tuesday morning. So if you have any problems, you've got to get to me by 11:30 on Friday. Otherwise, I'm not going to be available until Tuesday of spring break.
Thank you, Professor.
Okay. Okay, so let's first work on finding the common denominator. So in order to find the common denominator, what do we say the first step would be? Anybody tell me what they did?
Factor 2 out of 2x.
Right, you factor this and it becomes 2 times x plus 5.
Plus 5, yeah.
Okay, what did you do with the x squared minus 25?
I did the same thing.
Okay, and what'd you get?
X squared minus 5 squared.
No, what do we do when we have x squared minus? This is very important to know because they always ask these type of factoring. There's no common number that goes into them. Yes, it is. This is a perfect square and this is a perfect square. How do we break it up?
With minus 5 in each thing.
Right, x plus 5 and x minus 5. The difference of squares. Okay, thank you, Cheryl. Corey, you came up with it, great. Okay, so now we've got it factored. Now we've got to pick out what are our different factors so that we can find our common denominator. So remember what we do. We circle. The first thing I see is a 2. I circle it. The second thing I see is an x plus 5. I circle it because that's all part of the first fraction. And then I go to the second fraction. And then the first thing I see is an x plus 5. But I already have an x plus 5 circled. I don't have to circle it again. The second thing I see is an x minus 5. I don't have an x minus 5 circled, so I have to circle that. Which means my common denominator, I just write all the things that I circled. The 2, the x plus 5, and the x minus 5. That's my common denominator. Okay, now we have to look at the numerator. We have to see, what should we do? So I check. There's a 2 here. Well, there was a 2 originally there, so it's not. I check it off. There's an x plus 5 here, so I check off the x plus 5. What am I left with? I'm left with x minus 5. In other words, I have to take this x plus 4 that was there, and I have to put it in parentheses because it's a whole unit. The x plus 4, and I'm going to have to multiply it by this new guy, x minus 5. Whatever is, that's what not checked, that's what I multiply my numerator by. In the second fraction, let's see, I have an x plus 5 here, check off that x plus 5. I have an x minus 5, check it off. What don't I have? The 2. I'm going to have to multiply this 5 times 2. Well, that's easy. I can just write it as 10. This was not so easy, so I wrote it out. So what I have to do now is multiply these together and combine. I'm going to give you a couple minutes to try that. Multiply x plus 5 times x minus 5. These are good examples because you have to know how to do this for the midterm. You don't have to do this whole business, but for the midterm, you have to be able to multiply polynomials, specifically binomials. So multiply this and combine it with the negative 10 and see what you get. I'll give you a minute to try that. Okay, so let's do it together. I'm going to have to use FOIL to multiply the x plus 4 times the x minus 5. That'll give me x times x is x squared. Outer is negative 5x. Inner is plus 4x. And plus 4 times minus 5 is negative 20. And minus, now I'm going to minus this 10. I'm going to put everything over the common denominator of 2 times x plus 5 times x minus 5. And now I'm going to combine all, I'm going to go over here. These get long. I'm going to combine all my like terms. So it's going to be an x squared. Then it's going to be a negative 5x plus a 4x, which is a negative 1x. And then it's going to be a negative 20 and a negative 10, which gives me a negative 30. That's all over our 2, our x plus 5, and our x minus 5. And what we have to do is factor the numerator, the x squared minus 1x minus 30. Now I'm going to give you a couple minutes to try that. Factor the numerator. We're down to simplifying that fraction. Good job, Tivana.
Does the 10 to 11:30 a.m. account for extra time?
No, if you're entitled to extra time, you have to let me know so I can set it up for you.
Okay.
Anybody, I think I sent that out on an email. Anybody who's entitled to extra time from the DA office, email me. Somebody already did, and I've already got it set up. But you will be entitled to extra time, but that isn't the 10, actually, the 10 to 11, you really only get an hour and I think 20 minutes. There's an extra 10 minutes built into it because sometimes you don't get on right away. But once it starts, you're going to be, that time is gonna run out. Okay, so I see a couple of people have come up with this. Does somebody want to tell me what this factors into? How did you get, I think you know how to do the factoring. What did it come out to be? The x squared minus 1x minus 30. Anybody want to tell me what they got?
X plus 5 and X minus.
Perfect. X plus 5 and x minus 6. And that's all over the 2 times the x plus 5 times the x minus 5. Notice there is a like factor in the numerator and the denominator. I can cancel out the x plus 5 with the x plus 5. Don't make the mistake. You can't cancel out an x plus 5 with an x minus 5. It has to be identical. And your final answer then will come out to be x minus 6 in the numerator over 2 parentheses x minus 5. And you could write it that way. That's perfectly acceptable. Or if you want to, you could multiply out the 2 and write it as 2x minus 10. Both of these answers are completely acceptable answers. If you're getting something like this, and you won't get it on this test because this is in chapter 5, don't forget. But if it's on the final, they could give you either this answer or that answer. They can't give you both answers because they're both equally correct. So they can't give you 2 correct answers. Okay.
Professor, I'm here. April.
Yeah, I know you were here. I saw you
Okay.
on the list. I don't know. Okay, so I marked you here. Okay, so I want to start one more topic, and then at about 11:15, we still have about 25 minutes left to class. I'm going to go over, Jonathan asked me to review quadratic equations. I'm going to do that. If anybody else has a topic they'd want me to do, you can ask me. Of course, Melissa, you're going to have sessions after class. Is that correct?
I have one, Professor.
What?
I want to do finding the perimeter of something, like the length and the width.
Oh, okay. Yeah. Okay, so then we'll do one of each. So let me just quickly do one more topic, a question on similar to this, a little bit involving solving an equation. And then I'm going to do the perimeter problems, and I'm going to go over quadratic equations. What do we do when we want to solve an equation that has fractions? So there are going to be 2 different types. I'm just going to do the one type today. When we come back from spring break, we're going to be finishing up in the chapter 5 and going on to chapter 6. Right after spring break. So that's where we're going to be. We're going to be doing the last topic on chapter 5. I am not going to be assigning any specific homework on I probably might assign something on Delta Math on what we did on doing today, but I'm not going to give you a long assignment to do on Delta Math over the spring break. If you are behind, this spring break is a good time to catch up on anything that you're missing. If you see that you can't get into it, just email me. I will be checking my emails, even though it's spring break. Again, starting on Tuesday, I will be available. Okay, so what if I gave you an equation that looks like this? 6 over a minus 4 equals 3 over 8. This is an equation with fractions in it, where on each side you have a single fraction. One fraction on this side, one fraction on the other side. This type of equation is something called a proportion. You cannot have anything else added on either side. Each side is its own separate fraction. When you have a proportion, then one way to solve it is what's called cross multiplication. Which means you multiply each numerator with the opposite denominator. You multiply across the equal sign. So if you're doing that, you do 6 times 8.
48.
Which is going to be 48, correct? And that's going to be equal to a minus 4 times 3. You notice how it's like an X that we're doing this way and this way. That's why it's called cross multiplication. You really, but be careful. It has to have an equal sign in it, and you have to multiply the numerator of one with the denominator of the other. Notice it's not like multiplication of fractions, because when we just had plain fractions to multiply, we multiply the numerators together and we multiply the denominators together. Here, when you have an equal sign, you multiply a numerator by a denominator. What is the advantage of that? Well, over here we get 6 times 8, which is 48. And here we distribute the 3, we get 3a minus 12. It makes the equation a much simpler equation. All I have to do now is add 12 to both sides. So that'll give us 60 equals 3a. And I'll divide both sides by 3, which will give me that the a is 60 divided by 3, which is 20. So that method is called cross multiplying. I'm going to give you one to try. And see if we can come up with a here's one for you to try. Six over n minus 5 equals n over 4. I'm going to give you a few minutes to try that one. I just told you to check the truth. All right. Are we ready to try this one?
Yeah, I need to see it done again.
Okay. I see that some people, let's see, okay. Again, I have one fraction, 6 over n minus 5
Uh-huh.
equal n over 4. One fraction on one side, one fraction on the other side. So I can do this cross multiplication. So I can do the 6 times the 4, which of course is going to give me 24. And that's going to be equal to the n minus 5 times n. Now, when I multiply the n minus 5 times n, I have to use a distributive property. And that's going to give me n squared minus 5n. Remember, this times this equals, we have to put an equal between them. This is an equation, so you're going to have an equal sum. So I end up with 24 equal to n squared minus 5n. What is better about this is the fact there's no fractions. But what kind of an equation is this? Anybody?
An algebraic one.
Yeah, I know, but how am I going to solve this?
Can we distribute? I honestly don't know.
Anybody have any suggestions? Very good, Cheryl. She said it's a quadratic equation. She sees a square in it. Whenever you see a square, I mean, I don't know why they picked n for this particular example, but
Perfect. So we're gonna get two answers.
right.
Okay.
And
I
actually,
just second guessed myself because I'm like, wait a minute, the one previous to this, we only got one answer. Why am I getting two?
okay, but why are you going to get two answers to this and that one?
Because it's squared.
Right. And actually, I wanted to do this problem also because Jonathan asked me to review quadratic equations. This is from chapter 5. But once you're out over here, this is really what we learned how to do in chapter 4. What do we do when we have a quadratic equation? What's the first thing we have to do? What, do I leave it like this? What do we do when we have a quadratic equation? What do we have to get it equal to?
0.
0, right. And it's easier to get this side to be the 0 than this side to be the 0. So I'm going to get rid of this 24. I'm going to minus the 24 from both sides. In other words, I could go either way, but it's easier to go this way. So let's go that way. That'll give me 0 equals n squared minus 5n minus 24. So when I see that square, it tells me it's a quadratic equation, which tells me the next step is to get it equal to 0. And At this point, we have two options because it's an equation. Option number one is our factoring option. Option number two is our quadratic formula option. And as a review, I'm going to do both options. I'm going to do it both ways so that we see, you decide which method you prefer. If we're doing the factoring method, I have to do the AC, which is 1 times negative 24, which is negative 24, which means I'm going to be looking for numbers that multiply to 24, but when I subtract them, it's going to give me 5. And I think everybody would realize that it's 8 and 3, because 8 times 3 is 24, and when you subtract it, you get 5. And it's going to be the 8 being the negative, and the 3 being the positive. I'll bring down the n squared, or bring down the 24. Over here, my common factor is n, so I get n minus 8 in the parentheses. Over here, my common factor is positive 3, so I get n minus 8 in the parentheses as well. So this gives me n minus 8 and n plus 3. And we finished the factoring, but we're not finished with the problem because this is a quadratic equation. We're looking to solve it. We have to get separated. Let's go over here. We're going to separate it to n minus 8 equaling 0 and n plus 3 equaling 0. And here I'll add 8. So my one answer will be positive 8. And here I'll subtract 3. So my other answer is going to be negative 3. And right, you get 2 answers for this one. Even though it looks similar to what we did before, when we cross multiplied, in this case, we ended up with a square, which meant it was a quadratic equation. And that's why we ended up with 2 answers. Now, Jonathan, did that help you with what you wanted to know?
Yes, it did.
Do you want me to go back and do this using the quadratic? I think I should use the quadratic formula just to remind you how to use the quadratic formula. Though any quadratic equation that you will be getting on the midterm will definitely be factorable. You do not have to, the quadratic formula I taught, but it's really not part of the syllabus until later in the term. So you don't have to know at this point the quadratic formula, but let's just go back with this equation and do it using the quadratic formula, just to remind ourselves. Okay, so I get to the same place. I get to the point where I have the n squared minus 5n minus 24 equaling 0. Let me show you how we could have used the quadratic formula to solve this. Specifically, if you don't like to factor, when you have a quadratic equation, with factoring, you have to factor. If the question is asked about factoring, you have to factor. But with the quadratic equation, you could always use the formula. The formula being negative b plus or minus the square root of b squared minus 4ac, the whole thing over 2a. Okay, I'm going to erase this. I'm just going to leave the answer on the board to show you that it doesn't matter. The method will give you the same exact answer. For this particular example, and again, you have to get it equal to 0 before you can say what the A, the B, and the C is. The A in this case is the 1 because there's nothing in front of the n squared. The B is negative 5. because that's what's attached to the n. And the C is the negative 24. Don't forget to include the negative signs. So therefore, my answer is going to be wherever I see a letter, I'm going to put a parentheses. In place of the B, I put a parentheses and fill it with negative 5. Then I put this plus minus. And again, here's my parentheses for B. It's B squared. Again, I fill it with negative 5 minus 4. Now there's a parentheses for the A and a parentheses for the C. And in the A parentheses, I put my 1. And in the C parentheses, I put negative 24.
I guess.
And this is all over 2. And now I have a parentheses for the A. And again, I fill it with a 1. So I put a parentheses wherever I see a letter and fill it. That's why I like to write these A, B, and C down so I know what to fill it. There's a B, I fill it with a negative 5. There's a C, I fill it with a negative 24. It's just a matter of filling it up, and now we simplify. Negative times a negative 5 is a positive 5. Then we have plus or minus. Now here's where we have to be really careful. Negative 5 squared is negative 5 times negative 5, which is positive 25. And then I have negative 4 times 1 is negative 4. And negative 4 times negative 24 is plus 96. And when I add the 25 and the 96, I get 121. So this is the square root of 121 all over 2 times 1, which is 2. So yeah, the big thing when you're using that formula is simplifying what's inside your radical. Now the square root of 121, and if you don't know it, you really should, but it's you could do it on your calculator, happens to be 11. So this becomes 5 plus or minus 11 divided by 2. And once you get to this step, you have to divide it. This plus or minus means you have 2 answers. One answer you're going to get by doing 5 plus 11 divided by 2. And the other answer you're going to get by doing 5 minus 11 divided by 2. That's just a shorthand way of saying they're 2 separate answers. Now the 5 plus 11 is 16 divided by 2. So that gives you the 8. And the 5 minus 11 is negative 6 divided by 2, which gives you the negative 3. And you get the same exact answers, 8 and negative 3. So that is how you solve a quadratic equation using the quadratic formula. And now I think it's going to be clear to you why it was so important, why you had to learn how to factor, why you had to learn how to solve quadratic equation, because each chapter that we learn builds on the previous one. Okay. Does anybody have any question about this? Did you have any other questions on quadratics, Jonathan?
No, that's fine. You answered all my questions. Thank you.
Okay. So I want to answer, I think it was Ashley's question about perimeters. Let's
No,
do
Jennifer.
Who was it?
Jennifer.
It was Jennifer.
It was Jennifer. Okay, Jennifer.
Thank you, Jonathan.
Anytime.
Okay. So let me see if I can find a question that has a perimeter question, and let's see if we can do that one. gonna erase this now, and I'm gonna give you a question on perimeter. The length of a rectangle, I'm not gonna write of a rectangle, you know, is 5 more than twice the width. The perimeter is 70. Find the dimensions. Okay, I'm going to give you a couple minutes to try that on your own. Okay, I see we're running out of time a little bit, so let's do it. Here's my picture of a rectangle. They usually tell you what the length is in terms of the width. So pick your width to be X or W or whatever you want to call it. I usually like to call it X. And then write the length in terms of that. It says it's 5 more than twice the width. It could say 5 longer. 5 more or 5 longer means you're going to be adding 5. Twice the width means you're multiplying. It's the same as saying double or 2 times. So your length is 2x plus 5. If it would have said 5 less, it would have been 2x minus 5. So you're going to, when it says more, you're going to add the 5 at the end. When it says less or smaller, you're going to subtract the 5 at the end. Now, in a rectangle, the opposite sides are equal. So this one will also be x, and this will also be 2x plus 5. And the perimeter is the sum of all these sides added up. And I could do it right here because I have this picture. X, I'm just adding the x's. X plus 2x is 3x, 4x, 6x. All the x's added up gave me 6x. 5 plus 5 gave me 10. So the perimeter in terms of x is 6x plus 10. And they told me that the perimeter is 70. So here's my equation. 6x plus 10 equals 70. Now I just solve this equation by subtracting 10 from both sides. I get 6x equals 60. And when I divide both sides by 6, I get that my x is equal to 10. And then I go back and I see that they asked me to find the dimensions. And the word dimensions means both the length and the width. So I know the x is 10. So the width has to be 2 times 10, which is 20. 20 plus 5, so my length is 25. So either you can say it, length equals 25 and width equals 10, or you could say 25 by 10 or 10 by 25. They sometimes use a X in between to mean one side is 25 and one side is 10, but your dimensions are 10 and 25. Was that a help?
Yes, it was. Thank you.
Okay. All right, so
Yes.
it's now 11:30. I'm going to be leaving now. Again, don't forget, tomorrow, go to Blackboard.
Professor.
Yes,
So the midterm, okay, so I can go and study all this. The midterm will be exactly how we took the one before. It just
Right.
has 5 more questions.
right,
So it'll be perpendicular, everything that we've done from 1 to 4.
right. Plus, so the test that I gave you, and there are a few people who still have not taken it, and I've given you until tomorrow to finish taking that test. I extended it because some people did ask me. Those 15 questions were on chapters 1 through 3. The midterm includes chapter 4 as well, but we've been going over the questions I've been doing as do nows were the type of questions that you would see on the midterm from chapter 4. So you're going to have 20 questions. They're multiple choice questions, 4 answers for each. You have to pick the correct answer. Let me also keep saying, if you don't know how to do a problem, but you could somehow eliminate some of the answers, you know right away some answers are not right, at least it gives you a better chance to guess at the answer. For example, when you have a question about the line is parallel to another line, then you know right away the slopes have to be the same, so you can only pick answers that have the same slopes. Make sure you're doing your test. Not only should you be taking the test to show your knowledge, because that's really what it is, but you really have to take the test smart. There are people who they're not so good in math, but they're good at taking tests. So make sure you're using hints. If you run into a problem while taking the test, either, as some people did, it's submitted. Remember, I'm going to be available between 10 and 11:30. Make sure I'm going to be checking my emails. If not, if you can't get through to me, if I don't answer, you can try Melissa. Melissa has my phone number, she'll call me. But I will be checking my emails every 10, 15 minutes. If I'm not sitting at the computer, I'll be there and I'll walk away for 5 minutes, but I will be there. But I won't be there after 2 o'clock in the afternoon, even though I'm gonna leave it on. I'm gonna open it up, even though it says 10 to 11:30. I think I set it to open up at 9 and to close at I think 2 or 3. I don't remember, because to give the people who are entitled to extra time, the extra time. But if you're not entitled to extra time, it will automatically submit after the time is over. Does anybody have any questions they want to ask me still? Okay.
No, but happy Pesach.
Thank you so much. And we're having, I told you we're having a circumcision, a bris on Pesach. So that's going to be exciting.
Wow.
We have a new grandson and it's a lot of good things happening. And
Congratulations.
thank you. Everybody have
Enjoy.
rest and come back, because we have a lot to do when we come back. We only have about 5 weeks of class after we come back, and there's a lot of material to cover. I'm probably gonna have to be going a little bit faster. Okay, but
Right.
everybody stay healthy. I've been hearing terrible things about Florida and spring break and what's going on there. So don't do any crazy things over spring break. And if you haven't done, if you need something opened up, just send me an email. I will take care of it. Okay, bye-bye.
Thank you, Professor.
Melissa, I'm leaving you in charge. I know I'm leaving you in good hands.
Bye, Professor. Enjoy your break. Enjoy your
Bye-bye.
baby, your grandbaby. All right.
Thank you, thank you. Bye-bye.
Hello?
Hello.
Professor Lee?
Yes, I think she left. You weren't there?
No, I was in the bathroom.
Okay, I thought you were talking to her.
No, I went to the bathroom.
Okay, she left.
I can't stay today because I'm legit heading to the airport like in the next hour.
Okay, then. So,
But you guys have my email, so if you guys have any questions or anything, you guys can email me.
all right, then. Enjoy
Alrighty.
your vacation. Stay safe.
All right, same to you guys.
Yeah, thanks.
Bye.
Bye. Bye-bye.